A whole lot going on here in the next couple of videos. I'm going to introduce you to standard and extended ACLs. We're going to send some unusual pings. We're going to see how to apply ACLs, a whole lot going on. You also might want to grab something to write with if you still don't have your wildcard mask writing materials, because we're going to do a live lab here in a moment, and I'm not coming back to the drawing often while we're doing the lab, so you might want to write this one out. Now, let's talk about these standard ACLs for just a moment before we see them in action. A standard ACL can only match on the source IP address of the packet. That's it. When we're using iOS help here in a few minutes, and when we're writing a standard ACL, you'll see there's no destination IP address that you can enter, no port numbers, no nothing. Source IP address, and that's it. We do have two numeric ranges to choose from when writing standard ACLs. And I always say, do not freak out when I show you this full list of ACLs and the numbers, because I'll tell you a dirty little secret. As long as I've been doing this and teaching and working in complex life networks and studying for IE labs, there's still one or two in here that I've never used. So don't worry about memorizing all of these yet, but we will definitely get to some of them. And here it's just sending a couple of pings around. Let's do it right here on router 3. That's fine. And we'll do a CompT and an access list. And here are the ranges. Now, the first two that you got to have down cold are the two standard ACL ranges. The first one is 1 through 99, and the second one is 1300 through 1999. And note it says expanded range there in parent. And if you're totally new to ACLs, your first question might be, why do I have two ranges and why aren't they sequential? Why doesn't it just say 1 through 999 or something like that? Well, here's the deal. When Cisco first developed ACLs, when they first came into use, the thinking was we will never need more than 99 standard access lists. And of course, at one point, and some of you weren't even around for this, and that's fine, the thinking was, this floppy disk is the largest portable data storage unit I'm ever going to need. And while we were grateful to have them at the time, if you look at your laptop, you're probably not going to see a floppy drive right there. So time does march on. And the thing is, we needed some more standard ACL entries. We needed some more extended entries. So Cisco just made it, instead of rewriting everything, and we'll have to ask them why they didn't just make it sequential at the time. I don't know. They'd have to move everything around and all the different lists. So instead, they just made another set of numbers for us. So again, 1 through 99 and 1300 through 1999 are the standard ACL numbers. Now, there's no right or wrong. If you're writing a standard ACL, don't concern yourself, I should use a number from which set. Don't worry about that, but you do want to watch out for it in practice exams and on the real exam, that kind of thing. If you see a line in an ACL that mentions anything besides the source IP address and it's numbered as a standard ACL, there's something wrong with it. I mean, there's something terribly wrong, because you just can't do that. So those are the numbers for our standard access list, both the normal range and the expanded range. Now, since standard ACLs match only on source IP addresses, and I know you're already getting tired of hearing that, but that makes them kind of difficult to use in certain situations, like say this one. And here, I just left router 2 out. We've got the usual cloud connection between routers 1 and 3 over the 172.12.123 network. Usual serial interfaces there. I've got 2 loopbacks on router 1 and just 1 on router 3. And as you saw on the screen when it came up very quickly, all I did was check the connectivity here for router 3. And you can see that router 3 can ping the all 1's address, and router 3 can ping the all 11's address. I do not have a dynamic routing protocol in place. I just put a default static route on each router pointing to the other router, and that's not going to come into play in the lab. We just need a connectivity. So everything is just fine right now, but now we're going to have a set of requirements that we have to meet with an ACL. And here they are. First off, we want to block traffic sourced from 3330/24 if it's destined for the all 11's subnet. Now, router 1 should allow packets from 3330 if they're intended for any other subnet, including subnets we might add in the future. We're also told the ACL has to be applied on the serial interface of router 1. Now, is that a red herring? Does that really matter? I mean, we have to meet it, but does that really affect the configuration? Well, we'll see about that, but we're going to start right now with a standard ACL and see if we can actually even make that happen with a standard ACL. So we'll go over to router 1 first. And we want to write an ACL. I'll just use number 5 just for fun. After I learn how to type the word list. And you see the options deny, permit, remark. Remark we're going to come back to because that's going to be a little bit of a dad lecture. But that's just the way that you can actually comment on an ACL. And it's a good thing to do if you write a 32-line ACL. You should say, you know, a access list 5 remark. Here's what this is for. Because, you know, someone might come in a year from now and you're not there anymore. You've moved on to a better job and somebody's like, well, what does this ACL do? So I guess I gave you the dad lecture now. But we'll remark an ACL here. Nothing complex there. Right now we want to concentrate on deny and permit. And we wanted to deny traffic from 3330 as long as it was destined for 11.11.11.0. So let's do a deny. And we've got host name, any host, so we'll go with the network. .30. Geez, that period doesn't want to go in. There we go. So, coming up next, my wildcard mask. What should my wildcard mask be? And I want to use dotted decimal. I want to stick with that. It should be 000255. And there you go. That's all there is to it. Because, of course, we're saying the first 3 octets have to matter, 333, and then after that we don't care because the requirement specifically said, you know, hey, you want to block traffic from 3330/24. See, it didn't say just the one loopback that we saw in the diagram. Because if we were doing that, we would put in 3333/32. So that's what we've got so far. So what can we do now? What are the options? Well, with a standard ACL, we don't have any other options except log. And we don't want to log our choices right now or log our matches. So that's what we're going to go with. So here's a pop quiz for you. What is the net effect of this access list? It denies everything because we still have the implicit deny. And I know everybody out there just nailed that when I said, why is he asking me that? Well, here's why. Occasionally, people will look at the deny statement, the explicit deny, and think that it overrides the implicit deny. It does not. The only thing we can do about the implicit deny to get rid of it is to negate it with a permit any statement. So that's what we're going to put in right now. And that's it. So if I wanted to verify the lines and everything else, I could run show IP access list. That's going to show you your ACL. Note those numbers. We're coming back to those. But also note the order right now because we've got deny 3330 and then wildcard bits, exactly what we expect, and then a permit any statement at the end. So the implicit deny has actually been negated now. So what do we do with our outstanding ACL after we write it? We've got to apply it. You've got to apply it. And here's exactly how you do that. We're going to go to the interface in question. And the command is IP. It does not start with access. It starts with IP and it's access group. And you know the way I'm saying that it must be a little different for other uses, but for physical interfaces, then you've got to put IP access group. And now we're asked, you know, what number is it or what name did you give it? You can actually give an ACL a name. We're going to do a lab with that later as well. But right now we're just going to put 5 in. And now we still have to put another value in because it's not enough just to say IP access group and then the ACL. We have to apply it either inbound or outbound. And there's a limit of 1 each way. Okay, so you can have one ACL filtering inbound packets and other filtering outbound packets, no problem. But in which direction are we going to apply this particular ACL? Let's go back to the diagram for just a moment. If we're filtering packets from router 3 and they're coming in on serial 010, the keyword there is they're coming in. So we are definitely going to do in here. And that's it. No other options. That's it. So IP access group 5 in. So we've now written the ACL over on router 1. We've applied it, and we need now to test it. But there's a bit of an oddity here too as far as the testing is going to go. Because if I send a ping from router 3 right now straight to router 1, if I just use the old ping 172.12.123, excuse me, if I do ping 1111 or ping 1111.11.11, what is the source address of that ping going to be? Is it going to be 3330 because that's what we wrote the ACL for? Might need to eyeball that, and we're going to use a debug to see exactly what the source IP address of that ping would be and move on from there at the beginning of the very next video.